Hello, welcome to this course of Introduction to Aircraft Structures. This course offers a clear and detailed introduction to aircraft structures for anyone seeking an initial, industry-oriented understanding of how aircraft are designed, built, and maintained. An aircraft structure consists of an assembly of interconnected components, each designed to perform a specific function. These functions include generating aerodynamic forces, accommodating passengers and cargo, storing fuel, and supporting propulsion systems that produce thrust for flight. In addition to carrying operational loads, the structure also provides the framework that supports and integrates the numerous onboard systems essential for safe and efficient operation. The course is structured using the 6 topics listed here. It introduces the basic principles of structural layout, materials, manufacturing methods, maintenance, repairs, and regulatory considerations, using real-world aviation examples rather than heavy theory, while aligned with established industry practices and regulatory frameworks such as EASA and FAA. The course is aimed at beginners and provides a strong foundation for further study or entry into aviation-related technical roles. In the first module, we trace the journey of aircraft structures from early wood and fabric designs to today's advanced composite materials, to gain insights into the technological advancements that revolutionized aircraft design and made flight safer, more efficient, and capable of withstanding extreme conditions. In the second module, we will dive into the fundamental structural layout of aircraft, including the key components and their functions. This module covers primary and secondary structures, fuselage and wing arrangements, and essential parts like frames, spars, and ribs that ensure the integrity of an aircraft in flight. Next, we will explore the materials that define aircraft performance and safety. This module will delve into the properties of metals, composites, and advanced materials that are used in constructing aircraft, each selected for specific roles based on weight, strength, durability, and resilience. Aircraft construction is a blend of precision engineering and cutting-edge technology. We will learn about the manufacturing processes and the assembly techniques that ensure each part meets rigorous standards. Aircraft structures must be maintained to the highest standards for safety and longevity. This module covers the practices, methodologies, and repair techniques essential for managing structural integrity over an aircraft's operational life, including inspection protocols and common repair techniques. Finally, the aviation industry operates within a highly regulated environment. In the last module, we will understand the regulatory landscape, including the role of agencies like EASA and FAA, and the standards that guide the design, certification, and maintenance of aircraft structures. We will be reviewing few case studies by using the examples of Boeing 787 Airworthiness Directives and the supporting material from FAA websites. One may ask the question, what is an airworthiness directive? An airworthiness directive is a legally enforceable rule issued by an aviation authority, FAA, EASA, Extra, that requires corrective action when an unsafe condition exists in an aircraft, engine, propeller, or component. An AD mandates inspections, modifications, repairs, replacements, or operational limitations necessary to correct an unsafe condition and restore safe structural or aircraft integrity. From structure's point of view, ADs teach how structures actually fail in service. Studying airworthiness directives, ADs, allows us to see how aircraft structures actually behave in real service beyond idealized design assumptions. Each AD captures a real unsafe condition, such as fatigue cracking, corrosion, vibration, or load path weakness, and shows how it was detected, why it occurred, and how it was mitigated through inspection, modification, or operational limits. By analyzing ADs, students learn how structural reliability evolves over time, how damage tolerance and inspection intervals are validated in fleets, and how certification assumptions are refined by operational experience. In this way, ADs serve as practical case histories that connect structural mechanics theory to real-world failure modes, safety management, and continuous airworthiness.